London's Excel Centre at 5G World. I'm here with my colleague Ian. Ian, you were in this morning's first keynote sessions, and there was a pretty good panel discussion with some speakers from Verizon and Orange. What were the key takeaways from that?
Yeah, and I thought it was interesting to get the kind of contrast between Europe and the US in terms of what's happening with 5G. And they had Ronan Dunn there, who's the head of Verizon Wireless, but obviously used to work in the UK as head of O2, so he's quite a good person to sort of assess the differences and kind of talking about why they're moving more quickly in the US, and made the interesting point they have a lot of customers on unlimited offers using a massive amount of data every month, and he sort of sees these tariffs coming into Europe eventually, but this is where the efficiency benefits you get with 5G really come into play, that if that traffic is going to carry on going up, then keeping that cost per bit down is really, really important. The other thing is just access to spectrum. You know, they've got a lot of spectrum at Verizon Wireless. I think he said about 1,000 contiguous in these millimetre wave bands they're using. Now, there's some concerns about millimetre wave in terms of coverage and whether it goes through leaves and buildings, which he's obviously going to play down. But when coverage and whether it goes through leaves and buildings, which he's obviously going to play down. Now, there's some concerns about millimetre wave in terms of coverage and whether it goes through leaves and buildings, which he's obviously going to play down. But when it comes now, there's some concerns about millimetre wave in terms of coverage and whether it goes through leaves and buildings, which he's obviously going to play down. But when it comes to kind of providing really high-speed services, it's the stuff that you want. And the other key thing I think they're doing at Verizon Wireless is using it to get into sort of residential broadband opportunities they haven't been able to serve on a fixed line. So he made the good point that you can sort of build the networks once, but use it to kind of suit two use cases, and that's not really happening as much in Europe because there's kind of less of an issue there, I think, in a lot of Western European markets. So I think he's always interesting to hear. He kind of says what he thinks and made some really kind of clear points about where things are going.
And then Arno from Orange, he made some interesting points about spectrum.
Yeah, Arno's like, the European story is obviously that they're not moving as quickly, and he sort of acknowledges that. And one of the big issues there is just access to spectrum. You know, they don't have it. Arno van Paris, sorry. So he's kind of very much in charge of the 5G program on the technical side at Orange across the whole group, and Orange has got lots of networks in Europe as well as Africa, so the pace at which they introduce 5G is going to be quite different across all of them. But I think they've always talked about 2020, I think, for France as the kind of aim, and the issue really is the spectrum hasn't been made available in the French market yet. They're waiting for that to happen in the next few months, but until they get their hands on it, then they can't use it. And there's this ongoing concern about some of the moves that have been made in Europe, particularly in the German market, where some spectrum was kind of held back and will be provided at a later stage to industrial groups like Volkswagen. I think BASF have shown interest in acquiring that. That's gone down very, very badly in Germany among the operators. Obviously, they say it's driving up costs, it's reducing how much they're going to be able to use, which has an impact on service quality. So it's quite a controversial move. There's suggestions it could happen in France, which Orange has always played down in the past, but we had a question there sort of raising the possibility that some of the French industrial groups are now interested in getting that, which could have an impact on the process, I guess.
Yeah, absolutely. And then also this morning we heard from Dario Talmasio, from analyst from Ovum. He gave a view of where he's expecting the 5G market to go, but he kind of sort of said, you know, for the Europeans who are just starting off, you know, take a look at what's going on in South Korea, because, you know, there's already, I think, 3 operators there offering 5G services. That market's already taken off. We heard from the speaker from SK Telecom that there's already 1 million 5G subscriptions.
Yeah, I'm not sure that's been announced before either.
No,
so 1 million figure.
A bit of a scoopette.
Yes,
in English, in English language at least. And he made the point of the speaker made the point of saying that this is a faster uptake than it was for 4G. So it's pretty interesting. Obviously, there's quite a few advanced services being offered in Korea as well, VR and AR. They're still at the testing point for how edge computing is going to play into some of those. And then one of the other speakers as well was the Secretary of State for Digital, Jeremy Wright, and managed to get a little bit of commentary out of him on stage about what's going on in terms of the name Huawei was never actually mentioned, but
the vendor everybody's thinking of. I think
well, obviously, I mean, everybody in the UK just wants to know what is the UK government decision about whether Huawei technology is going to be allowed to be used in 5G networks. That certainty is needed by the operators. So when are we going to get it? But he said, the wait might be a bit longer.
You asked the question, and he basically said things that are happening in the US could have an impact on this. Basically, I think is what he said.
The goalposts are moving,
and I think it is a bit worrying, I think, for UK operators, because if this drags on, and Brexit is also sort of affecting this now. We've had Donald Trump visiting recently, kind of suggesting that unless the UK does things that he wants to see done, then they might not get the kind of favourable trade deal they get in a post-Brexit world.
Don't start me.
But I mean, I guess if you're a UK operator, and I've talked to a few of them recently, it's just the uncertainty. You're talking about now building out the networks, and if they have to, EE was saying it wants to get so many sites up and running each month. If they have to they're obviously having discussions at the moment. Do we move ahead and start building out Huawei equipment? Because eventually they're going to have to take all of that out, and that's a cost they don't want to have to bear.
EE, I mean, there's
Three's very heavily
Vodafone.
So 3 of the 4 network operators heavily dependent. The only one's not is O2, which Ronan used to run.
Right.
So he didn't use Huawei there, and he obviously not using it now.
Right. Yes, not in the US, that's for sure. Okay, so there's quite a lot to take in the first sessions. We've got 2 days of 5G chat and hopefully some gossip. So let's catch up at the end of the event and see what else we found out.
Sounds good.
So that's 5G and the industrial Internet of Things, and a lot of insiders who all know what they're talking about, and a lot of us people down here outside the industry who haven't a clue what they're talking about, because it's also technical. So we don't even know the names of the companies, and we don't really know what artificial intelligence is, but we've just got to go and look. So this is one of the biggest companies. We don't really understand how AI is transforming everything. We don't really understand about on-device artificial intelligence and why it's becoming ubiquitous. But I've been listening to some stuff from Google Talks this year at their expo, their 1.0 expo, and everything they were talking about is how on-device artificial intelligence, what that means is you don't have the artificial intelligence up in the cloud and have to rely on sending information up to the cloud and back down, which isn't really up to a cloud, by the way, because it's all actually in data centers and stuff. It's not really in clouds, or if it is, they haven't really released that information yet. So artificial intelligence on your device, which is to say that they've got the artificial intelligence so highly advanced now that it fits on nanometer chips, and it fits on a tiny amount of memory compared to what it used to take when these things were the size of a whole building. But the smaller they make the nanotechnology is, the more powerful the technology is. So the smaller things get is the less latency, which is to say, because the information doesn't have to travel very far. If you send something down a wire that's going a mile, it takes quite a while to go that mile down a wire. Whereas if you're sending something that's just on a tiny little nanometer chip, then it's got almost no distance to travel. So this is part of how it's all getting faster. But basically, unless we go and learn all about what these guys are doing by going to their friggin' websites and listening to their very long, boring talks, then we're just never going to find out what the heck it is that they're at. And my main point about what I'm saying, or why bother making this video, is because so much of what I'm seeing being shared out there in Facebook groups where people are trying to stop 5G, they're not really aware of what 5G actually is. and they're thinking it's got something to do with their mobile phones and having a better signal for their mobile phones. Well, it's just nothing to do with having a better signal for your mobile phone, and it's everything to do with the industrial Internet of Things, which is everything to do with industry, which is everything beyond your mobile phone, which is everything to do with automated factories and automated cars and automated trucks and automated ports and automated cities and automated garbage and automated everything. So there's the Internet of Things, which we're sold as being like, oh, that's your fridge is going to be able to tell you when you've run out of milk. But really, that's again just selling us stuff that we know a tiny bit about, like, oh, we know what milk is and we know it can go sour. But we don't really know about how a port runs, or how to track every single package that's been sent to anywhere on the planet, or track every single human who's been sent to anywhere on the planet. And most people don't know that individual humans are considered to be things in law, that a person is a thing. So when we're considered to be persons, rather than a man or a woman, then we're actually a thing, we're accounted for, we're chattel, we're to be organised, we're a resource, a human resource. It's pretty crazy, really. So this is Qualcomm's website, and you can just go to these things and learn for yourself what the heck they're all at.
This is a time of rapid innovation. Unlike anything we've seen before, where AI lives in the hand and in the cloud, making for smarter, faster interactions. This is the time to remove barriers and accelerate progress. This is the invention age. It starts with Qualcomm.
That's all the kind of stuff that we thought was just in films, and it turns out this is the kind of stuff that's in technology that is in our homes any minute now. Ubiquitous AI. Has anybody ever heard of that? I didn't even used to know what the word ubiquitous even means. It means absolutely everywhere, unavoidable. So go and look into transhumanism and what artificial intelligence is, or AI, call it alien intelligence, because really it's completely alien to this planet and it's completely destroying the nature of this planet, and it don't give a fuck about the nature of this planet. And when it speaks of ecosystems, it doesn't mean nature, it means computer systems, it means financial systems. The cloud in mind, and your mind in the cloud. So all of this is programming. All of this is programming our minds. At 7 nanometers, that means the thing is, what, 700 times smaller than the thickness of your hair? As far as I've learned so far.
FCR Wireless News. My name's Sean Kinney. We're here in the Qualcomm booth, and Yongmin, you just showed us a very interesting demo about coordinated multi-point spectrum sharing for 5G NRU. But before we talk a little bit more about that, I wanted to look back first. You know, as LTE developed, it wasn't until quite late in that cycle that we saw LTE unlicensed and then LAA, which was really a key development. So now that we already have these work items in front of 3GPP related to 5G NRU, how do you think that portends the development of 5G NR for unlicensed as compared to what we saw with LTE?
Yeah, that's a very great question. So when we, in LTE days, when we started NR LTE unlicensed, and we started working on the LAA in release 13. So ELAA will be release 14. Now, obviously, through that process, we learn a lot of things. And over the years, we already see some deployment from operators in the North America and other regions. So all the things we learn over a year become an experience for us. We can build into the 5G unlicensed. We can really optimize the system even from very beginning for the unlicensed use.
So right now, 3GPP has two study item open for.
My name is Gabriel Brown with Heavy Reading, and I'm here with Qualcomm to talk about 5G for industrial IoT. This has emerged as really one of the most important of the advanced 5G use cases. A lot of pull from industry, the future customers, a lot of attention from operators, and really a lot of R&D focused on this application from the vendor and technology ecosystem. So we're going to run through a demo. Pirapol, take it away.
Thank you, Gabriel. In this demo, we are showcasing the capabilities of 5G that can be applied to industrial IoT. In particularly in this demo, we are showing smart manufacturing and factory automation. We are showing a typical use of 5G that can be applied into factory. So for example, there are multiple cases where we can utilize 5G from industrial robot to handheld terminal to sensors, and all of these use cases can be supported on 5G in a single network.
Okay, so that kind of maps pretty nicely to the famous 5G triangle. I guess there's some of these applications you can support on a private LTE, right, already?
Good question. So there are some of the use cases like the handheld terminal that can already be supported by private LTE, but there are additional use cases that previously used to be very challenging to be supported by wireless technology. For example, industrial robot and motion control, those previously are being done using cable connection. So for wireline replacement, we need to be able to meet this 6-9 reliability in a challenging environment such as the factory, and this is very difficult for wireless communication. So let me illustrate why. So in a typical factory environment, there are a lot of objects that can move around, and many of them are made of metal. So in typical wireless communication, when you have this base station that communicates to the device here, when objects such as forklift move nearby and block the signal, then the signal gets weaker, and then we have packet loss. So that's a problem for reliable communication over wireless. In 5G, we have a technique that's called coordinated multipoint, or COM, that allows these different base stations to coordinate together and then jointly transmit the signal that combine constructively at the device, which allow the device to have very strong signal at all times, even with obstruction. Now let's go to the actual test result that we have from our test bed in San Diego. So this is the result from our over-the-air test bed in San Diego, where we have 4 base stations installed in different corners of the factory and a device that are in the middle. So as you can see, when the device is being blocked by this forklift, the signal drop off very sharply, and that causes packet errors, which is a problem for reliable communication. And this is resolved with our COM. So with COM, as you can see, even when the forklift come and block the device, the signal only dip slightly, and more importantly, there are no packet errors, even in this challenging environment, because the device can still receive strong signal from other base stations that are not blocked. So in order to convince you that we can actually achieve 6-9 reliability, what we do is we need to generate many millions of packets. So we run the system over 24 hours to compare without COM and with COM. How do we improve the reliability? So first, let's take a look at the result without COM. So as you can see, in this result, because we park the forklift right in front of the device, so the reliability goes down because the forklift keeps blocking the signal. Now, when we turn on COM, in similar situation, eventually we'll see that for the total of 86 million packets, we only have 50 packet errors. And if you look at the reliability of the system, we always have a 99.999% reliability or 6-9 reliability that's achieved with our technology. For the system such as this, it can be operated on a variety of frequency. Either operators can provide a system on operator licensed spectrum, or this system can also be operated on what we call locally licensed spectrum, where government may allocate certain parts of the spectrum that allow enterprise to deploy the system locally. So there are a lot of options here. So there are many capabilities that are already standardized in release 15. In release 16, there are further improvements to enhance the ultra-reliable low-latency communication to make the system more reliable and also more efficient in, for example, the control channel of the system, along with support for time-sensitive networking, which allow 5G system to be interoperable with legacy equipment that support industrial Ethernet.
So you're saying they're mapping the industrial Ethernet standards onto 5G NR radio interface, so you're going to get the same performance as you'll get from these specialized Ethernet connections over wireless.
That's correct.
Terrific, thank you. Very impressive. Thank you very much, Pierre-Paul.
Thank you, Gabriel.
So these people are really talking about how to industrialize the natural world, as far as I can see. So they're taking technology that's for inside a warehouse and they're applying it to high-speed trains and to buses and to cars and to motorways and to farming and to satellites and to weather and to sensors on bridges, and everything in the natural world is now becoming part of an industrial Internet of Things. That's pretty fucking crazy as far as I can, like, it's unbelievable really, until you listen to, type in transhumanist into YouTube or whatever else and just listen to these transhumanists over the last 20 years talking about what their history is and what their beliefs are and what their intention is, and how they consider that anybody who is unaware of what technology can do for extending the life of a human or for uploading our minds into the artificial intelligence cloud and being able to download our mind back into a robot body or a pig's body or a dog's body or whatever, or into a cyborg body, or just to be able to live inside in a cloud thinking that they retain soul or intelligence. These guys are pretty crazy as far as I'm concerned, and I'd never wanted to look into what are they doing until this 5G thing made me wonder what the heck is it all really about. And this is the kind of thing that I'm finding out as to what it's all really about. So do something as simple as do a search for 5G and the IIoT and find out who Cisco are, find out who each of these companies are, and have a listen to what they're saying, because someone like Mark Steele or any of these other experts who are apparently raising people's awareness but actually raising a whole load of fear about what 5G is, to my mind, they're not really explaining the context of what 5G is, and they're raising an awful lot of fear. Now, the fear may be worthwhile, but you've got to be a little bit accurate about what the fear is really about, because it's not simply that it's military, and it's a bit over the deep end to say that it's military which is going to be used to wipe us all out as humans. Yeah, that may be what's happening, but that's not really helping us to understand who's doing this, how's it come about, and I don't really hear Mark Steele or anyone else talking about how artificial intelligence is really what's at the back of all of this, about how all of our governments are all signed up to all of this, about how the United Nations are the super international, they're beyond nations, they're transnational, getting all countries to sign up to their agendas, and those agendas are Agenda 21 and Agenda 2030 and the habitat, and you got to go and look at. There's just too much to tell about, but hey, maybe I'll make the effort to make the videos to try and share all this awareness. But to be honest, it's more like teaching people how to fish. You've really just got to go and type things into the internet and read and listen to and put the time into finding out for yourself instead of believing other people, because who's paying the other people to host their websites or to, I don't know, personally there's a lot of dodgy information flying around causing an awful lot of arguments between people. Is this really what you want for machines to see and understand like humans? Do many of you know about how the artificial intelligence has been learning how to read human emotions by looking at us from our devices and studying us?
When we think about AI and its capability to actually help us, to enrich our lives, we know we need to first help machines see and understand like humans do. Take this drone collecting data in 3D, or this autonomous vehicle with cameras covering a 360 degrees view. Current deep learning technology can analyze 2D images very well. But how can we teach a machine to make sense of image data from a curved object, like a sphere? And because we want this processing to happen on the device itself, for reliability, immediacy, and privacy reasons, how can we achieve this in a power-efficient manner? It turns out we can do this by applying the mathematics behind general relativity and quantum field theory to deep learning. To accomplish this, Qualcomm Technologies is researching a new type of convolutional neural network. We call it a gauge equivariant convolutional neural network. Our neural network takes in data on virtually any kind of curved object and applies a new type of convolution to it. We can move the shape around and the AI will still recognize it. And here's the real breakthrough. We make this process highly efficient by approximating and unfolding the shape in flat 2D patches so it can run on an AI-powered car, drone, or VR headset. This is just one example of the exciting research we're doing at Qualcomm AI Research to shape AI in the near future.
So, before 5G, phones always used the same low part of the spectrum, right? Then what happened?
Then we have the high bands, which have never been used for cellular communication before. These are known as the millimeter wave bands.
That's interesting. Why were they never used until 5G?
These bands, the amount of bandwidth is extremely high, but the propagation is not very good. So you have to have much more closer cell sites to the user. It allows us to be far more precise in terms of transmitting to a given user.
More precise?
Think of the difference between a flashlight, which kind of floods everyone in the room, versus a laser pointer, which can pinpoint a given user. But because the beam width is so small, there can be a complete blockage. If the user is walking past a light pole, that light pole can completely block that specific beam. So there is a beam that's tracking the user, and then if that doesn't work out, the user immediately switches to a different beam. We call this adaptive beam switching. The user can always switch back and forth between multiple beams. I walk around with it, I drive with it, and I don't care whether I'm close to the base station or not. That's when we knew, okay, there is some potential now. Now we can do something with it.
You didn't celebrate or anything?
We very rarely pause and celebrate the fact that we've solved a challenge. Maybe we should do that a little more.
Thank you, Durga.
Mm-hmm.
Where's the bag of all DVDs?
What's the biggest thing we'll notice about 5G?
So I think the biggest thing is the massive data rates and the low latency. We are going to have a capacity going all the way up to like 5 gigabits per second on day one.
Can you tell me more about latency?
Look at it as like two people talking to each other. You're both taking turns talking, and you can talk, pause, and wait for like 5 minutes for acknowledgement, or you can talk, pause, and wait for 1 minute. You can imagine the smaller and smaller we make these intervals, we increase communication between two people.
Got it. Latency is gap time, and if there's less gap time, then communication happens faster. Why does that matter?
Think about mission critical applications like remote robotic surgeries. How quickly you can respond is extremely important, because that could be a life and death scenario. Or autonomous cars. Because if you are detecting a collision and you need to send that to the car behind you, it's extremely important that message gets to that place. There's no point telling you to avoid a collision after the collision has happened.
What's it feel like now that you're starting to see this in the world?
One of the cool things about working on technologies in Qualcomm is you cannot say hello to a stranger without them potentially owning something that you have developed. They say, oh, look what my phone can do, and you feel so good saying, yes, I know exactly why it does that and why it can do that. And I think that's a great feeling.
Thanks, Vinitha.
Artificial intelligence is really techniques that help machines and computers mimic human behavior. It's like a Russian nesting doll. Artificial intelligence at the highest level is the device being smart. How it becomes smart under the hood then is the next layer of machine learning, which are the general techniques or a variety of techniques that are used to make that device smart. And then there's a further subset of algorithms or techniques called deep learning. Artificial intelligence is going to be used in everything. So I'll give you two examples. If a car has intelligence built in, so it can see the world. So looking at what's on the road, looking at you as the driver, and being able to anticipate and course correct when something goes wrong, something jumps into the road. Autonomous vehicles of any kind are not going to be autonomous without artificial intelligence. In the medical field, new treatments that'll come from the analysis of reams of data to detect cancers and diseases. Today, machines are smart, and they're smart because of AI. But AI still has a dependency on us, people. We're making it possible. The next phase is when artificial intelligence is able to walk on its own. Companies like Qualcomm, if we do our jobs right, and if artificial intelligence is done right, the actual implementation is totally transparent to a consumer. But what they end up with is devices in their world that are more than utilities. They're actually experiential, and they will make your life easier, more exciting. This is truly a transformational technology. It's that big.
Since the 1800s. And you should too. And all of this is available on weathermodificationhistory.com/newspapers. So check that out. Go through these. I mean, it'll take you clear up to today. Man-made snow. This is one of my favorite ones. Another triumph by men who plan beyond tomorrow.
Or a gig is enough. Forget it. We need more data rate. So I came up with this wireless roadmap when our first startup, Systemonic, was bought by Philips Semiconductor, NXP, and I was chief scientist and had to meet the CTO, and I told him, I think you have to invest in cellular and in wired Wi-Fi because there is a continuous race going on, and he didn't believe it. And I sketched these lines, and I said, in 2015, we're going to have 100 megabit per second in cellular, and everybody said, that guy stayed in Berkeley for too long and inhaled too much. Anyhow, so what you see this here is now, today, 100 megs is not what we want. We want more than that. And obviously, if we talk about a terabit Wi-Fi system, that's only, what is it now? 8 years ahead from us. And we will have something even up to a terabit in cellular. So the question is not, will this happen? The question is how to do this. And this is a total fun part of research, of how to do research and actually look at this and drive this wireless roadmap forward. So this has been the content of 2G, 3G, 4G. You see 2G, 3G, 4G. And now 5G is going to come up. And 5G is addressing this also, like a 5G phase 1 with the new radio, we're going to see this happening. But 5G is more than that. And let's think of two new aspects, two new doors that are being opened, actually, if you think of 5G. One of them I like calling the thing book. We are human beings, and as human beings, we try to collect and hunt different things, so we want to monitor and sense all kinds of things, yes? So we have all kinds of sensors everywhere on planet Earth that we would like to have, and if we were able to have a sensor connect directly to the cellular network with a AAA battery and running for 10 years, and continuously giving us some information, this would be great. Then we would buy this, if it costs like $1 a year. Now that's maybe a market that is big, maybe 10 billion units a year, but not that big. Why? Because comparing this to what can happen, if we put this sensor into the cellular concept, this means we have a back channel. We don't only collect, but we can switch. We can turn things on and off. We can have every light bulb having a narrowband IoT sensor in there. And with that, basically turn on and off light bulbs, have things turn on and off. You can even, if you lost your phone and you want to know where it is, you just turn it on because it has an additional narrowband IoT sensor. And then, if we add positioning to it, as is being done in the narrowband IoT standards coming in June, we can track and tag all kinds of devices. And this is a gigantic market. Just think of it. FedEx, UPS, DHL, and all these companies send out 500 billion envelopes and packets a year. So this is about 1 trillion units a year that you can sort of start selling. This is huge. So this is the market of narrowband IoT. And this is something we don't know of today. And this has a ton of challenges ahead. If I am selling 1 trillion units a year, Some of them, like on a FedEx envelope, are only active for 2 weeks until they reach the destination. Others are active much longer. How do I manage these things? I have to be able to build a whole infrastructure in managing these devices, because just think of it. If you sold this service as an operator and it costs $1 a year, and suddenly you find out, oops, something went wrong and somebody's calling 1-800-HELP-ME, the business proposition is gone. So you need to be able to build a whole infrastructure, not only in terms of chips, but also service, monitoring, operations of this kind of system. And finally, we're seeing the game of the millisecond coming. So the tactile internet, as we name it. What is that? So 7 years ago, when I was on sabbatical in Berkeley, I was thinking, looking at my cell phone and thinking, so bigger screen, nicer screen, more pixels, what else? And as I was moving it, I thought, actually, I'm moving it, I'm seeing some visual interaction. I'm moving it, I'm controlling it. So if we touch and move an object in front of our eyes, what is the reaction time our visual system, our eyes, want to see this so that it seems real? So if we do this remotely and we move this, we can see a lag time, or we cannot see a lag time. If it's real time, we don't see a lag time. It turns out the lag time that is allowable is in the range of 1 millisecond. If we're really moving an object in 3D, it's 1 millisecond. If we're moving a mouse over our screen, it is 10 milliseconds. So it's somewhere in the 1 to 10 millisecond. It's not. And depending upon what the human being's visual skills are, it's different. Anyhow, so it sure is by far a big step forward from what we have today in terms of LTE with 50 millisecond round time. Who knows that the millisecond counts? The gamers. Why? Because speed of light is really slow, because light only travels at 300 kilometers per millisecond, which means if you want to do internet gaming, real time over the Atlantic or over the Pacific, there's no chance because the speed of light is too slow. You're going to get way more than 10 milliseconds. And if we go to a fiber optic cable, it's even slower. It's only 200 kilometers per millisecond, so a little more than 120 miles per millisecond. That's not much. Now, what is it, however, that we also know from gaming? That is, if we put VR goggles on and move our head back and forth, we can get sick to our stomach. Why? Because it doesn't react in the millisecond. So we really need to make sure that these VR goggles are pretty good and are understood. Otherwise, our poor leaders of the nations will start getting oozy. And we don't want that to happen. So what we said is, so here's a friend of mine, Frank Fitzek, colleague of mine in Dresden, and we sat down and said, let's try to see if this millisecond really makes sense. Everybody talks about it. No, nobody talks about it at that time. Today, everybody talks about it. But at that time, nobody talks about it. And so we said, let's build an experiment. So we say, take an Oculus, put 2 cameras on top, and so now we can set the delay time of what you see and what you get into a different mode. And you see here, this poor student is trying to catch the ball and is actually using his whole body. Now we crank up the latency to 150 to 200 milliseconds. And what you see is not very fair, because you see that this person is not really catching the ball. And why? Because if I throw an object, the speed of the object is about 1 centimeter per millisecond. And here you see at minimal lag time, the guy is catching the ball, but with about 10 centimeter displacement because of the 10 millisecond lag time. So it really is our natural human way of interacting with the network. And that is very interesting, because I think to make the network more human, it just has to be in the millisecond range. Obviously, that's the human side, which is interesting, so we can extend our skills. So some people talk about the Internet of Skills. We can do all kinds of things in terms of that, but it is not only about humans, the millisecond, it's also all over the place. It is if we start controlling robots. The robot actually should move at the speed of our motion, because if you move this robot with a remote control, it's really cumbersome. What we want to do is go in there with a humanoid robot and control it. We want to see what the robot sees with VR goggles. We want to control the object and actually run it as it sees. And finally, if we then go to the millisecond in factory automation, it's happening today already. It's there because these robots are actually controlled in the millisecond range. Why is that? They have about 1.50 meters dimension. So if two robots pick up jointly an object, they want to have a smooth motion and not jittering and jerking around and getting sort of Parkinson, right? Self-resonation system there. And to counter any self-resonance build-up, you have to sample 10 times per period, and that's why in control, everything is in the millisecond. So getting rid of the cables is big, because that is one of the big expenses in running a factory, because these cables break and you always have to replace them. Getting power there is not the issue. But once you have a wirelessly connected robot, you can actually have a mobile whizzing on the factory ceiling and factory floor, picking up the pieces in time, on time, and actually do an in-time manufacturing of an individualized product. So what is the future of shopping? You go to a store, you don't see what you have on, you see something else. When you move, it should be reacting in the millisecond time frame, obviously the virtual mirror. Then you can feel different fabrics, you choose whatever you want, you push, I want this. We need a design assistant to help us, so very great job opportunity for artistically inclined people. Then it's manufactured individually in this individualized manufacturing plant, send off, and we get it back. And this is a complete new way of going to boutique stores and boutique design systems. Finally, I want to touch a little bit on the automotive side, just to give you an idea that the millisecond plays a role in automotive. Where could it play a role tomorrow already? That is, if you're the green car and you want to know if there's an orange car coming because you would like to pass the two slow cars in front of you. Obviously, what can we do? All cars these days more or less have cameras built inside, so we could actually connect these cameras, have a rendering system to give it a bird's eye view, render this together with the Apple Maps or Google Maps database, and then, based on that, actually calculate a bird's eye view in real time of what's happening, and just put this in your heads-up display. And then as you're driving, you're seeing actually in real time if a kid is running into the street, if some object is in the way. Just think of this added level of security. Now, there is a millisecond in the cars today already, which you see in this experiment. Here are two completely identical cars. The left car has electronic stability control, the right one does not. Exact identical cars, different brands, but same car. This is by the German equivalent of the AAA, ADAC, a test done there. So what we see is, to actually stabilize a car, we need this control loop between the wheels. Why is it 2 milliseconds? Because the wheels are about 3 meters apart, resonance frequency 50 hertz, and as I said, 10 times sampling per period, so that gives us then the 2 millisecond reaction time. If we now go to the next level and want to build platoons of cars, we have to get this 2 millisecond reaction time into the platoons. So we have to connect the electronic stability control and the whole motion control, not only of one car, but of all cars. In a car-to-car scenario, this is an n-square problem of connectivity. Or we have an infrastructure that takes care of that. Once we have an infrastructure, we can do all kinds of crazy things. Anyhow, so Bosch gave us this thing that there is an issue coming up, and we didn't know this, so we set up this experiment here with Lego Mindstorms. Kids from 9th grade kids that spend 2 weeks at our labs in Dresden, at the 5G lab in Dresden, they put this together, and so they're tracking this black line, they're keeping a constant distance. What you don't see is that they're at the border of chaos. Because what happens is, one car is actually accelerating, slowing down, accelerating, slowing down, and the second one, the third one as well, to keep a constant distance. If you have more than 3 cars doing this, you see this jerkiness, you see a chaotic system happening, and this is the reason why if cars on a freeway are too close to each other, and the car in front of you is stopping while you are actually accelerating, you overreact, and if the car behind you is also starting to overreact, you get a spontaneous traffic jam. And obviously we want to get rid of these spontaneous traffic jams because we want to get rid of traffic lights altogether. We want to have cars whiz and crisscross over intersections. We want our personal bubble to be turned on so that we as a human just can cross the street and we are guaranteed nothing has happened. And obviously even the frog with the 5G modem is going to be a happy camper. So with this in mind, I I can show you here a demo that we had last year at Mobile World Congress where we had this in action, and you see this car stops and everything is really nice with 2 base stations and the mobile edge cloud actually controlling these cars. This is the future. Now, if we look and take this one step further, obviously we take this into verticals, and this is the only vertical I want to touch and then finish, which is precision farming. In precision farming, what we want to do is we want to increase the productivity of farming on planet Earth by a factor 2 if possible. Verticals, and this is the only vertical I want to touch and then finish, which is precision farming. In precision farming, what we want to do is we want to increase the productivity of farming on planet Earth by a factor 2 if possible, to really make sure that everybody is happy. So we need drones flying around to scan the field to make sure that no deer is hiding there, and it's going to touch and then finish, which is precision farming. In precision farming, what we want to do is we want to increase the productivity of farming on planet Earth by a factor 2 if possible, to really make sure that everybody is happy. So we a factor 2 if possible, to really make sure that everybody is happy. So we need drones flying around to scan the field to make sure that no deer is hiding there, and is going to be hopefully not chopped up by the by this machine. Everything is completely controlled, because then you can compact the soil at the same pot where you compacted last year. You can increase the productivity of the other soil. And it's a big challenge, and we went out into the field, and here's some videos of our measurement on a tractor to see if this really can work, and if we can actually have these latencies and delay times in the field to operate these kind of systems, and these tractors at 2.5 centimeter at 1 inch precision. With this, I would say I gave you an idea of what this is about the tactile internet. It is a new era. If you think cordless telephony was it, when I lived in the States in the early 90s, everybody thought cordless is it, and that's about what we need. But cellular, actually making sure that we can initiate a call anywhere and reach on anybody anywhere, and not only when they're close to a base station, is the killer app of wireless communication of cellular. So this is now happening, and we're taking it to the Internet of Things. With the tactile internet, we're going to do the exact same thing for remote controls. Today, a remote control is a point-to-point. Doing this via an infrastructure can make sure that drones, cars, whatever, fly along routes that are safe, and this is revolutionizing all these different industries. So we're at the doorstep of another 30 years ahead of us of revolution. With control is a point-to-point. Doing this via an infrastructure can make sure that drones, cars, whatever, fly along routes that are safe, and this is revolutionizing all these different industries. So we're at the doorstep of another 30 years ahead of us of revolution. With this, of us of revolution. So we're at the doorstep of another 30 years ahead of us of revolution. With this, I would like to thank you for listening, and I hope I gave you a little bit of an idea. So 5G is really exciting. It's about data rates, it's about massive Internet of Things, and it's about the tactile internet. And the 2 new game changers are massive IoT and tactile internet, building the infrastructure for remote controls. And with this, we have a happy 30 years ahead of us. Thank you.
So today we will be talking about lethal autonomous weapons and what they are. So they're basically weapon systems that are able to select and fire at a target without the intervention of a human. So that seems pretty complex and crazy. So how it works is that the weapon is going to assess the situation in the battlefield and decide if it should attack or not based on the processed information that is inputted